Dear students, welcome to the knowledge series. We are going to discuss on Dijkstra's algorithm to find the shortest path for the given figure. Using this figure, we have to create a routing table. So, to do this task, here you can view two figures. On the top figure, every link is being assigned. In the bottom figure, one link is missing between B and D. Other things remains as it is. To start this figure with the solutions, we have to do two steps. One step for individual figures, that is first to assign the weights, and next is to find the new weights. That new weight will be based on the relaxation conditions that I have already discussed in the earlier video series, which you can watch for the better understanding. So by applying the relaxation conditions, we will be getting the weights. That weight is what I have been highlighted over here, and followed by there is still further discussions we will do so that you can understand this concept. But it is always better to watch the previous video series. Now, with respect to this figure, let us create the routing table. So a grid is being put across here so that I can directly go and fill these segments. So let us start this task. To start this work, let me first of all assign the vertex to this grid. So I start with the vertex because there are different vertices there, S, A, B, D and T. So let me put it like that one. S, A, B, D and T. Similarly on the row columns, there also let me put S, A, B, D and T. Now we will consider that from a given vertex, when we move to the corresponding different vertexes, how we are going to assign the different weights. As you can see here, S is is the starting point. Let me put here S is a starting point. This is a start, and this is a end point. Similarly, this is also start, and this is a end point. Now, with respect to these different vertex, we will be filling these sections. From a given vertex S, once it travels to its own point, so we can assign the weight as 0. And from S to A, when it travels its vertex weight at A, it's 8. Its weight is 8. Similarly to B, it is 3, and to D, it is 5, and to T, it is 8. From next we will do the same thing from a given point 8, A. A to A is what? It is 0. And next we go from A to B. A to B, if this is 0, and then if you add that one, add to this vertex, so automatically we will be getting 0 plus the link cost is, it will be getting as 5. Then to D 5 we are getting over to B. Similarly, when we compute with respect to A to D, we will, because since it is a indirect node, so when we try to compute it with respect to the normal Dijkstra algorithm steps, we will be getting the value as 5. And since it is a direct node, so we will be getting this one as 2. And from A to S, when we try to compute it, because A to S is the point when we try to compute it, as far as the previous case we have seen that A to S is 8. Now coming to the B to B itself is 0. Those things we can do itself directly. D to D is 0 and T to T is 0. That is a straightforward. Now coming from B to S. So this is 3. So automatically B to S will be 3. Then B to A. So it is 0 plus 5 is 5. Then B to D. So automatically B to D is 0 plus 2 is 2. Then B to T. T, if you look across, here it is 0 plus 7. It is 7. But when we are looking the other process, and when we try to compute it, and when we try to do the relaxation conditions, we will be getting the value as 5. And this process we are continuing for the next. Then we are going with the next D. D is here. D to we are calculating for D to D is 0. Then D to B. If it is 0 here, so automatically at this particular point, because when we try to see D to B, 0 plus 2 is 2. Then D to T, 0 plus 3, 3. D to A, this is again a indirect nodes. So when we try to do the corresponding computations, we will be getting it as 5. And D to S, again it is indirect nodes, we will be getting it as 5. And next, with respect to T to T, it is 0. T to D, it is again going to be 3. T to B, it is when we try to do the computation of a T to B, because with respect to B, there are several other links factor is coming. T to B, it is going to become as 5. T to A, again it is a direct link, so automatically you will be putting as 2. And T to S, automatically T to S, based on the different conditions, we will be seeing it on as 8, because S to T is already 8, so you are getting that 8 over here. So only the case is A to T, it was 2, so that's why T to A is again a 2. So like that, different combinations we are putting it based on the first factors. When we are seeing these nodes, this is the neighboring nodes, whereas in these nodes we are not visited, and we consider are not visited. This is a visiting nodes. whereas this is not not visitor. So when we are using this one as a visiting node, automatically, because of the additional link coming, so the weight will try to change. So this is one combinations of creating these tables. So when we create this particular table, that reflects the solutions of this particular figure. Now when we are considering this figure, how this particular scenario changes when the link breaks. So let us once again rewrite these figures. So we are writing this one here again. We are writing here S, A, B, D and T. Here S, A, B, D, T. Now we will try to see how it is again going. Now S to S, it is 0. S to S is again, it is 0. Let us put it here as 0. S to A. S to A is when we try to see based on the S to A how it is going here and also through this path. So you can see the 8 and 10. So automatically it is selected as smallest one. Then S to B is 3 because it's a now if you see across D, S to D, if you go, you can go like this, you can go like this, you can go like this. So you will be finding that if you are going in this path, say 3, S, B, T, D, 3 plus 7, 10 plus 3, 13. Or S, B, A, D, A, T and D. Then 3 plus 5, 8 plus 2, 10 plus 3, 13. But if you are going S, A, T, D, 10 plus 2, 12 plus 3, 15. It is higher. So you select S to D as the shortest path, that is appearing as 13. S to T. So automatically you find whether you go this way or you go this way also, you find it as shortest as with respect to 10, because 8 plus 2, 10, 7 plus 3 plus 7, 10. That is SBT is 10, SBAT is also 10. So that's how. Now all the own node weight with respect to its own distance is considered as 0. So once we wrote this one, now we will look from the A to the corresponding. So A to S is what? A to S is not a direct path, because it has it is giving a weight with respect to direct and indirect path, where the indirect path is short. So that's why it is 8. And A to B, it itself remains as same. So it is a 5. Then A to D. If you look across, this is 2 and this is 3. So automatically it is 5. A to T, it remains with this is 0. 0 plus 2 is 2. Now with respect to B we will compare. B to B is 0. Then B to A, it's a state, so it is 5. B to S, it's a state, it is 3. B to then which one? D. B to D. So 7 plus 3 is 10, or 5 plus 2, 7 plus 3 is 10. And B to T, it is 7. That's. Now if you consider D with respect to the other, D to D is 0, then D to T. When we consider D to T is 3. Then we consider D to the next node we can consider as, say, B. When we consider D to B is 3 plus 7, 10. Then B to D to A. D to A is 3 plus 2, 5. D to S. When we consider here 3 plus 2, 5 plus 10, 15. 3 plus 7, 10 plus 3, 13. 3 plus 2, 5 plus 5, 10. Then 3, 13. So it is 13. Then we consider T. T to D. T to D is automatically it is 3. 0 plus 3. Then when say T to B. T to B is automatically it is 7. 0 plus 7, 7. T to A, 0 plus 2 is 2. T to S. T to S is, you can see, we can go like this. So T8S, TBS, TBAS, like that also we go. Among all this one, if you go like this one, 10, 12, 2 plus 10. If you go like this, then 7 plus 5, 12 plus 10, 22. If you go like this, 7 plus 3, 10. So we find it as 10. So this is the solutions with respect to this problem. That means using a routing table, when it asks, when you find this type of problem and when it is asked in the exams, you have to create the routing table, and based on the routing table you have to solve this problem. Here one thing is very easy to remember is that you find that this path, this particular path is, it remains same, and that is this link. This is always 0, this path. Here also you can see this is considered as 0. Only with respect to the because of the existence of the link, you have to look for the best solutions. How you compare to find the. Now, for example, if you see here T to B is what? 5. Now you may think how it is T to B, because T to B is going like this, like this, like this also. You can go from T to B. So if you are going like this, or going like this, among all this, the minimum is this one, 5. So this how we solve the numerical problems of the Dijkstra's algorithm using the routing tables also. So with this we come to the end of these solutions. Thank you.